of the topics that you are going to have on this test. Okay, so this would be section 3.4. In your book, it's divided into 2 sections. It's only really 1 section in a journal when we teach this. Okay, so let's see. A very nice test, and most of the time we are going to use this test rather than the other one that did it. Okay, so this is going to be a 3.4. Okay, and today is Thursday. Okay, with 7.6. That's it. 3.4. What is the second derivative test? We already talked about the first. Second derivative. Okay, derivative test. We are going to use it quite a lot, so we refer to it as a second derivative test. Remember, in the case of the first derivative, when we want to identify the maximum and the minimum, remember this is what we did. We look at the graph. Okay, so that was the graph. That was the minimum. So how we describe the minimum with the first derivative test, we look for the f prime. For this case, we check the sign of the f prime before it's negative, after it's positive. So if the f prime is going to be down and then up, then the point is going to be minimum. And the other way around for the maximum, okay, the other way around is going to be the maximum. So if this point is going to be maximum, again, we check to see the function going to be increasing or decreasing. So this is going to be up, f prime positive, the function, the graph increasing, and down, f prime negative, and the function is going to be decreasing. That is first derivative test. Okay. Now, what is going to be the second? For the second one, we are going to look at the second derivative test. You see, we look at this. We look to see how the graph would be curving up or curving down around these 2 points. We call it the notion of the concavity. So the concavity would be this one. You see, this is the same thing. You see, for this graph, if you check the tangent line at any point you like, you see the tangent line at any point you like, the graph of the function is above its tangent line. When it's going to be above its tangent line, we say it's curving upward. Curving up, or we say concave up. When the graph is going to be curving upward, then you have the minimum here. You see, this is going to be your minimum again. So we look at the concavity, if you like. And it's going to be the same for the, for the other case. If you consider this graph, and if you check any tangent line here, tangent line, so your graph is going to be below its tangent line. So this one is going to be called concave, concave upward, and this is going to create that give it the maximum. We're going to call this one concave, concave downward, or curving, curving up and curving down. So we are going to investigate this. In order to investigate it, you see, we already talked about the f prime. So in order to get to this one, your function f prime must be increasing. Remember, if a function is increasing, then the derivative of the function is positive. Since your function is already f prime, so derivative of the f prime would be f double prime, second derivative. So this case will happen if f double prime is going to be, it's going to be positive. And in this case, this will happen if f double prime happen to be negative. Very easy test. So we find the critical value, we drop it into the f prime. If f prime positive, we say it's a concave up. So the point is the minimum. If the f prime is negative, we say it's a concave down. We say the point is the maximum. That's second derivative test. But I have to define what is the concavity. And then at the end, what is going to be the second derivative test? Okay, that's what we are going to do. So we give one problem to find the distribution of the concavity for us, and one problem to find use the second derivative test to give us whether the point is going to be maximum or is going to be minimum. Very easy test to use. We most of the time use this one. Concavity is very important in calculus 1. We just use it in order to analyze the test, okay? But if you want to go to the space function of 3 variables in calculus 3, this is the concept that we are going to use. When you talk about the maximum and the minimum of the functions, which is defined in a space, okay, 3 variables or 2 variables, this method is complicated to use. They use only the second derivative test. I have my calculus 3 class. After your class, we are exactly at this for the function of 2 variables. So that would be important. The concavity is going to be changed a little bit. There is something else related to this one that we don't teach in calculus 1. And that one is when you drive, okay, when you drive with your car, okay. So when you get to the curve, you see the car automatically would curve, will bend if you like. So these type of ideas are going to be used to measure how, measurements of how you bend the curves, if you like. And it's used in designing the, freeways, designing the roller coasters, and it's used in optics for eye surgery. So it's quite an interesting concept. But in calculus 1, just staying with the menu of the course, and we're just talking about this concavity. Okay, so just give you the hint that what is going to be in future. So there you are. So I have to define what does mean the concavity, and then like the one that we did before, we draw a table and we take care of it, and that would be the second derivative test. Okay, are you ready? So what is concavity? We just take care of this notation first. Concavity. So again, suppose we have a function. Suppose a function, okay, a function f is going to be over here differentiable, is differentiable on some domain on an interval, okay, interval I. This is going to be the case. Now I'm going to define concave up, concave what? The graph. Okay, the graph of y equal to the f of x is going to be, that's the expression, concave upward or curving up. This is the same thing. Concave upward. Okay, concave upward on I. If there are different ways to express it, this is the way it's defined in your book. If f prime is increasing, it's like this slope, it's up, 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 up. And the graph is concave downward. If it's going to be concave downward. Okay, concave down. If f prime is going to be decreasing. That is one way to define it. Okay. F prime positive, F prime increasing is up, up, up as a function as you go on, and decreasing is going to be down, down, down. But if you put it inside, just in geometry, that would be easier for you to understand. From geometrical point of view, this means if the graph of the function is above its tangent line, it's concave up. Below its tangent line, it's concave downward. That would be easier to follow. So we mentioned this one too. From geometry point of view, geometrically, this is it. We define it again, the graph Okay, the graph y equal to the f of x is going to be concave upward. Okay, concave upward on I if it lies above its tangent line, curving up. If the graph it lies above all of its tangent line, it's a tangent line. So that would be curving up, tangent lines, okay, in that interval, and is a concave downward. It's going to be below its tangent line, concave downward. If the graph or it lies below, okay, lies below its tangent line. It's tangent lines. It's easier, to follow, but you can pick any. We're going to use both of them. So that's it. And this is the graph. You see this graph is curving up, concave up. But if you pick any tangent line, you see any tangent line, these are tangent line, always your graph is above its tangent line. So this is going to be a concave upward graph. And from the other point of view, f prime must be increasing. If f prime, the condition is in this case, f prime is increasing. So when f prime is increasing, you know that if the function is increasing, the derivative of the function must be positive, but the function is f prime. So derivative of f prime would be f double prime, second derivative. So this is the condition. Any question? Concave up, if you want to talk about concavity, you have to go to the second derivative. Second derivative positive means up. Similarly, we're getting the other one. So the similar one is going to be this one. This is the graph. It's concave downward. If you consider the tangent line, okay, these are going to be a tangent line, whatever tangent line you pick, your graph is going to be below its tangent line. So this is curving down, concave downward. So a concave, okay, a concave downward. Concave downward graph. So again, in this case, as said, first definition that you have f prime is going to be decreasing, going down. And if a function is decreasing, the derivative of the function must be negative. So that gives you f double prime to be negative. That's it. So that would be a test. We make it official as a theorem. And the graph is going to be concave upward if the second derivative is positive. The graph is going to be concave downward if the second derivative is negative. So positive up, negative down. Okay. So make it official. We make it official as a theorem and we use it. And you get one question on this one. A function would be given, and they ask you to figure out the concavity of them. Okay, are you ready? I'm going to go to the next page and give you this, we call it concavity test. It's going to be used for analyzing the graph of the function. Okay, so whatever I did is just a theorem. So what is going to be this theorem? This theorem would be referred to it as concavity. Okay, concavity test. This is the one that we're going to use to check it for us. Exactly as I talk about it. Second derivative positive concave upward, second derivative negative concave down. Okay, are you ready? So this is going to be the statement of your theorem. Suppose we have a function. Okay, suppose f is a function. F is going to be a function. It's going to be defined on an interval. Okay, on I, interval I that we talk about it, such that, of course, you must make sure that you can find the second derivative. So such that f prime, the first derivative, and f double prime, second derivative, both of them exist, because otherwise you can't do it. Okay, exist on that interval I. Because if you cannot go to the second derivative, you can't do it. Now, as soon as you find the second derivative, you are going to have two possibilities. First one, you check the sign of the f prime. You need a table for the f prime. So the first case is going to be if the second derivative, if f double prime of x is going to be positive on I, positive for all x in that domain I. If this is going to be the case, then the graph of f is concave upward, positive up. Then the graph, okay, the graph of your function, y equal to the f of x, okay, is concave upward. That's it. So simply, this is, you have to check. You can write it down for yourself as your formula shared. Okay, so this is it. You see the graph upward. This is where f double prime is positive. So positive up. Any question? It's just part of the definition that we talk about it. Case two, the other way around. If the second derivative happened to be, okay, if f double prime of x happened to be negative, again for all x in I, negative means done. It's concave downward. Just, imagine all the time the geometry of this graph. That would help you. Then the graph y equal to the f of x is going to be this time concave downward. It is concave. Okay, it's going to be concave downward. Okay, downward on I. That's it. Again, this is what you imagine and think about it. This is it. Down. Concave downward. This means f double prime is negative. So negative down, positive up. That's it. That is concavity test. And we do it right away. As I told you, this is going to be used for that. We find the measure that, the bending measure, they call it curvature. And as you move on, you see if you go around the freeway somewhere, you see if this is going to be the way you drive. So the way when they want to design it, the way they do it, at any point, they are going to measure that bending measurements. In order to bend it, you see this is going to be, at this point, it's going to be curving down, this is going to be curving up, it's going to be down, up, etc. But if you take calculus 3, we give you something else, we call it curvature. Okay, that's it. Curvature. Curvature is the measurements that you are going to find out how you're going to bend it. It's the measurement that your car know it. When you drive to get to the bend, if you have a good car and driving or Otago highway, the car will do it for you. Okay, when we get to the bending. The way they design it, they consider the curvature of a circle. You see, at any point, they consider a circle. For the circle, it's very easy to find out. Okay, if you get two circles over here, you see if you have two circles, this is one of them, and this is the other one. If you drive, you get to the roundabout. Which one is easier to to go around, the first one or the second one? When you drive on your car and you get to these two roundabout, which one is easier for you to go around, the first one or the second one? Any suggestion?
The first one.
First one easier. Which one, we talk about that curvature that we're going to have. You see, the second one is easier. If the roundabout is going to be a big one, when you drive with your car, that would be easier. This would be very hard. And the reason is these measurements that we're going to have, we call it curvature, they denote by K. If you have a circle, the curvature, the measurement that we use for designing the roads, it's going to be a reciprocal of the radius. So the radius of this circle is very small, so the curvature is very, very large. The radius of this circle is very large, so the curvature is going to be small. So the curvature of this one, if you call this one K1, and if you call this one K2, of course, it's easier to do the K2 because the K2 is going to be less than K1. It's the way they measure, the curvatures. This circle will be referred to as a kissing circle. So at any point on the road, the measurements that you have to curve is going to be the same as the curvature of a circle. And this is the way they design those, when you ride on the roller coasters, okay, or driving, this is the way they do it. And they use it in optic, and they use it for eye surgeries. So that's, that's a background of this type of ideas. If you are going to be interested to check curvature on internet, you will see it. The formula that we have is depends on the second derivative. Okay, now, I just want to motivate it to see how important it's going to be this one, but we are going to pass it quickly in calculus 1. Now, before giving you the example, you see, look at these curves. And there is going to be a point that this direction would be changed. You see almost here, if you like. So you are curving down, then you have to curve up. This point is going to be called inflection points. And you are required to find it. So before giving you example, we have to know what is inflection point or point of inflection. Okay, but again, all of them are going to be using sketching the graph of the function. So what's going to be inflection point? It's a point at which this direction of the curvature will be different. So a point. Okay, a point on the graph. A point on the graph of y equal to the f of x, where it's like the critical point, where the concavity changes. Okay, changes is called, okay, it's going to be called an inflection point. An inflection point. So for example, this is going to be the case. If you have this is the one. So as you can see, this is down, this is up. Almost there's going to be a place here, for example. A place here that it would be changed. So we call it point of inflection. Okay, this is going to be the case. It's like the critical point. In order to find it, you have to go for the second derivative test. Okay, I'm not going to prove it, but we give you a hint that it can be proved that if let's say C and f of C is an inflection point, is like the critical point, inflection point of y equal to the f of x, then there are two possibilities. F double prime of C is equal to 0, or F double prime of C does not exist. It's like the critical point that you use. Remember, F prime of C equal to the 0, or F prime of C does not exist. It's the same thing, but you have to find it with this chart that we have. So this means in order to find it, again, you must look for the F double prime to find out whether you are going to have, but you have to check it. You have to check the sign around it to get these numbers done. Okay, any question? So this is concavity. The reward is second derivative test, but first we have to check one problem. So on the test, we give you one function and we ask you to tell us. It's going to be a polynomial. We are going to ask you whether where the graph of the function is concave up, where the graph is concave down, and what is the inflection point. This is the only problem, is nothing to do with the f prime, nothing to do with the maximum and the minimum. We are interested in concavity, okay, concavity of the road. So the only thing that you have to do is you find f double prime. You let it equal to 0, and we give us a chart. On your chart, wherever f double prime is positive, you say it's concave up. When f double prime is negative, you say it's concave down. If you get up and down, you get the inflection points. I'll give you one, you see. It's very easy question. Most of the people, they miss this one with the maximum and the minimum. This would be different from the second derivative test, okay? Because we are not interested. This is the only problem, that we are not interested in the critical value on the test. So don't miss it. Okay, there you are. Example 1 on the test. And we have a couple of them to practice. That's it. Find the interval. Find the interval. Find the interval where the graph, okay, where the graph of the function, this is the function f of x equal to the x cubed minus 3x plus 1 is concave upward, is concave. Okay, concave upward or concave downward, or concave downward. And they ask you determine any inflection point. Determine or find any possible okay, inflection point or points, sometimes points. You see, that's a concavity problem. One polynomial would be given to, and yes, you see, nothing to do with the maximum and the minimum. So in order to do this problem, this is how we're going to do it. Solution. You determine the domain first. It's a polynomial. The domain is all real numbers. And what you have to do is look at this. Solve this equation. F double prime of x equal to the 0. That gives you the possibility of those inflection points. Okay, nothing to do with the critical values. Don't miss it. Don't waste your time. You know, some people, they find the critical values maximum, minimum first, then they go for the concavity. No, right on, F double prime. Okay, check the derivative. F prime first. F prime would be, you differentiate 3x squared minus 3. Don't stop here, continue. Differentiate it again. Again, this would be now f double prime, second derivative. Differentiate it 2 times 3, 6, 6x. This is where you're going to stop. You need this one, f double prime for the concavity. Okay, let it equal to the 0 to find the possible inflection point. Is equal to the 0, so that gives us 6x equal to the 0. So x would be 0. That's x equal to the 0. Drop it back into the function, find f of 0. F of 0 into the function would be 0 plus 1, which is equal to 1. So f of 0 equal to 1. So this would be 0, 1. This is the possible inflection point, but possible. You need a chart. You need to check the sign of the f double prime around this point to tell us where the graph is concave upward or where the graph is concave downward. Okay, so chart. So remember, this is the second chart. This first chart that we talked about it was the chart for the increasing, decreasing, and this is the chart for the concavity. So it's going to be x from negative infinity to positive infinity. You put your inflection point of x equal to the 0. You have only 1 0 to check. You're checking f double prime. F double prime. F double prime is 0 is here. So you have 2 partitions to check. And as 0, this is 1. But in this case, you have to give us the shape of the graph, concavity. Concavity. Any question? So that's a concavity table if you like. Okay, concavity chart. Concavity chart. And you have to give us this concavity chart. Now you bring the f double prime and check the signs. You see f double prime. F double prime of x is 6x. So you want to find out what is going to be the sign before 0 and after 0. You pick some numbers. You see between negative infinity and 0, you pick one number. You can pick anything you like. We call it test number. So for example, I pick negative 1. Then if you put the negative 1 here, so that gives you 6 times negative 1, which is a negative 6. It's negative. So f double prime is negative here. When f double prime is negative, that's concavity. Negative means down. So the graph is going to be concave downward here. That's it. Any question? So you check the sign of the f double prime by picking a number, a test number, we call it. Any number would do it for you. I picked the negative 1, so f double prime is negative. So the second derivative is negative in this region. Second derivative negative means it's concave downward. Any question? Do the same thing here. Pick a number here. For example, I pick 1. Okay, so I pick 1, so I check 1. So I check the 1 here, f double prime of 1. You don't have to write this on the test if you just know it. I just do it separately. So that gives me 6 times 1, which is 6. Now this is positive. So f double prime positive, concavity. Positive means up, up. That's it. You see, down, up. That gives you, in fact, the shape of the graph, you see. We can use it later to graph it. So down, up, since you have 2 different directions around the 0, so this point is going to be, okay, so at this point, you are going to get the inflection point, denoted by I. If you give me table over here, and that's fine, we accept it. But otherwise, you have to explain it. So the explanation is going to be the graph is, you see, this is it, the graph of y equal to the f of x is concave downward, is concave. Okay, concave downward in this interval on negative infinity up to the 0, and you see inflection point, and concave upward, concave upward between 0 and positive infinity on 0 and positive infinity. Then you declare that the 0, 1 is an inflection point. Inflection point. This is where you are going to get the 10 points from this one on the test. Okay, it's an easy question, but make it short. Nothing to do with f prime. I've seen some people, they let f prime equal to 0, they find the critical values maximum. No, it's just a concavity problem. You go to the f double prime quickly, you find it, let it equal to 0, you may get one solution or two solutions. Then you put it on the chart here. Then you just test some numbers. You may be able to do it if it's quadratic, as we did the other day, but the testing the numbers is going to be very useful. So check the sign of the f double prime. Negative means down, curving down. Positive means up. If you get it down, up, it's inflection points. That's it. Give me this chart. You don't need to change this shape. You don't need to explain anything. Everything is going to be self-explained. That's it. That's a concavity. Any question? Now the reward is second derivative test. So what's going to be second derivative test as we talk about it? We're going to have a critical values. Now we drop the critical value into the f double prime. So we find f double prime of C. No chart is needed. If f double prime of C is positive, means that you are here because it's concave up, you get the minimum. If f double prime of C is negative, means you are here to get a maximum. You see, nice test. It's easier than the first derivative test. And most of the time, we are going to use the second derivative test. Or for some problems, it would be useful better. But you have to know both of them both. Okay, so there you are. This is our last theorem and last test that we're going to have. So second derivative test, the reward of the concavity. Second derivative. Okay, second derivative test. We're going to refer to the second derivative test, SDT. Here you are. So we have a critical value, we want to check it. That's it. Suppose f is a given function, is a given function. Okay, given function on the domain D, domain of the function, and C is a number. C is a critical value. Okay, C and C in D is a critical number or value, is a critical value such that f prime of C is equal to 0. This is where you find it. Remember, critical values are coming from two sources. One that f prime of C equal to the 0 and f prime of C does not exist. You cannot use the second part for this test because you need to go to the second derivative. Okay, so that's why I put this one here. Okay, it can be used only for this type of critical values. So we let f prime x equal to 0, we find the C. So now we know we want to check to see if at C, we are going to get the maximum or the minimum. So what we do is we find the second derivative. So if we find the second derivative and we drop the C in it, if f double prime of C happen to be positive, you see f double prime is concavity. Positive means up. Up, you get a minimum. Then f of C is going to be a relative, okay, relative minimum. minimum. That's it. Very easy to remember. You see, remember this. Up. Your f double prime, you see, this is where the f double prime of C is positive. So this means around the C here, okay, the concavity is up. So in this case, this point is going to be a minimum. Okay, up, minimum. Just get the shape of the graph to remember it. Okay, second case, if f double prime, no chart is needed. If f double prime of C is negative, negative means done. Done means maximum. Then f of C is a relative, okay, relative maximum. Maximum. That's it. Again, you see, as soon as you see f double prime, this is the shape of the graph. It's done. When it's done, this is a maximum. Maximum. So this would happen, you see, this would happen when f double prime of C, of course, is going to be negative. That's it. Again, get the shape of the graph. That would be quick to remember it. Of course, there is going to be a third possibility. If you are going to be unlucky, you may get f double prime of C equal to the 0. If you get equal to the 0, bad luck, you cannot use this test. You have to go back and use the first derivative test. Okay, so test fails. Test. Okay, the test fails. So this means you have to go back and use the first derivative test. Okay, in this case, to check it. Okay, so that's going to be the one. The proof is very easy. It's exactly the concavity that we have. We pick a neighborhood around the C a little bit to the right, to the left, and you get the same thing that we're going to have. Okay, so this is second derivative test. So for the second derivative test, you have to find the critical values, you drop it into the function, but for the testing, you decide. So now you have two options, the first derivative test or the second one. You can pick either one through your experience to find out, but on this test, we are going to give you the name because we want to check it. So we give you, apply the second derivative test to do the job. So you have to. But in general, that would be your option to do it. But in this test, you will see one on first derivative test and one for a second. But later on, you get to know them when you go to when we have more functions. Okay, but for this test, we give the instruction. So one question with the second derivative test and one concavity. That make it to the 11 question. Let's give one example. Say we're going to do it, then we can go over your same problem from your practice one. Okay, so there you are. Example: a function would be given, and you've been asked to apply the second derivative test. There you are. Apply. Okay, apply the second derivative test. The second derivative. Apply the second derivative test to find. Okay, to find relative extrema means maximum and minimum of each function. I'm going to give you two of each function. Here you are. The first one, a polynomial. F of x equal to the x cubed minus 9x squared, okay, plus 24x minus 10. There you are. You know that step one is as usual. You have to find the critical values. So do the first job first, okay, first part first. You find the critical values, you drop them into the function, you find the candidate. Then for testing, you have two options. You can use first derivatives or the second one. But in this problem, since they say the second, so you have to follow the order and do the second, okay? So this is it, solution. You start with the domain, of course. The domain is all real number. And then you are going to solve, solve f prime of x equal to the 0 to find the critical values first. Okay, carefully differentiate. F prime of x is going to be equal to the 3x squared minus 18x plus 24. That's f prime. We're going to use it a couple of times, so highlight it so you're not going to lose it. Let it equal to the 0 to find the possible critical values. So we have the 3x squared minus 18x plus 24 equal to the 0. You want to solve this equation, try to see if you can factor out 3. In this case, it's possible, so pull out the 3. So that gives you x squared minus 6x plus 8 equal to the 0. So now we can handle it by factoring. So it's going to be 3 times 2 numbers with the product of 8 and the difference of 6. Of course, are going to be 4 and 2. X minus 4 times x minus 2 equal to the 0. So you let each factor to be equal to get the solution. 3 equal to the 0 never. So that gives you nothing, but for the second part, that gives you x equal to 4. And the other part would be x equal to 2. So the critical values are going to be 2 and 4. That would be step 1. Any question? Look carefully note this. Solve this equation, double check it. Make sure you have no difficulty. Okay. So next step, you drop this back into the function to find the candidate. You know that maximum value, minimum value, not these numbers. So you have to find them, then test it. Okay, going to the next page and continue. So the second part is going to be evaluation. So I have my critical values, which are going to be 2 and 4. So drop back into the function to find the candidates, f of 2. Original function. Okay, just go to the function. It was x cubed minus 9,8. So it's 2 cubed. Okay, minus 9 times 2 squared into the function, plus 24 times 2 minus 10. That is the function. Now 2 cubed would be 8. Minus 2 squared would be 4, 36. And that would be 48 and minus 10. Okay. So 10 and 36 would be 46. That give a positive 2, and 8 would be 10. So that would be 10. So the first candidate is f of 2 equal to the 10. You have to check to see if this is a maximum or a minimum. Okay, repeat it. Drop the 4. So find, plug in the 4. So f of 4 equal to, substitute again the original function. So it's going to be 4 cubed minus 9 times 4 squared plus 24 times 4 minus 10. Get this one. Okay, 4 cubed, 4 times 4, 16. 16 times 4, 64. So that gives 64 minus 4 squared would be 16. 16 times 9 would be 144. Okay, then we have 4 times 28. 4 times 4, 16, 96. So that gives 96 and minus 10. So take care of this one. 64 and 96 would be 160. Okay, 160, but this is going to be, this is a 160 minus 154. So the result would be 6. So f of 4 is going to be equal to the equal to the 6. So these are two candidates for the maximum and the minimum. Any question? Now you have to test it. Test for the maximum. We call it testing. Testing. You see, we have two options. First derivative test and the second one. But in this problem, they ask you to use the second, so you have to. So we are going to use the second derivative. Okay, it's testing, second derivative test. We have the first derivative test. Okay, I'm going to repeat this one quite a lot. We already talked about it, you know that. So the testing, second derivative test. So for the second derivative, you check the concavity, bring the f double prime. Remember, remind yourself, what is f prime of x? So f prime of x is 3x squared minus 18x, okay, plus 24. So get the second derivative. So that gives f double prime of x, carefully differentiate it again. 2 times 3 would be 6. We get the 6x minus 18. That is the second derivative function. Now bring those numbers and test them for the concavity. Numbers. We have a 2 and 4. So we check the 2 first, x equal to 2. You drop it into the f double prime, concavity. Okay, so that's going to be 6 times 2 minus 18. So that gives you 12 minus 18. 12 minus 18 would be negative 6. It's negative. It is concavity, direction of the curve. Negative means up. It's up, curving up, so it is minimum. It's the way you explain it on the test for us. Okay. Oh, I'm sorry, I made a mistake. Oh, negative means done. I said that, but I didn't write down. Okay, sorry about that. It's a negative. So negative means what? Negative means done. Curving down. When it's a done, it is maximum. So you explain that f of 2, which is equal to the 10, is a relative maximum. Any question? Some people on the test, they make a mistake. They say negative 6 is a relative maximum. Negative 6 is a testing number. Your point, remember, is 2 and 10. And this is the way we write it down. F of 2 equal to 10 is a relative maximum, the best way to write down. Any question? So we did have 2 points. Check 4. So checking 4. X equal to 4. X equal to 4. So we have to check f double prime of 4. Same thing. 6 times 4. 6 times 4 minus 18. So that gives you 24 minus 18. 24 minus 18 would be 6. But this is a positive 6. Concavity positive means up. Up. Upward. So we get a minimum. So this means f of 4. The value of the function, remember, is 6. Equal to the 6 is a relative. Okay, it's going to be a relative minimum. And you're done. You see, it's very nice test. It's very nice, it's quick, and you can use it, okay, anytime you like to get these numbers. Any question? Now, this test can be used most of the time, okay? But there is a surprise, a couple of examples that you may not be able to use it, okay? So this is going to be our second example to check it. But if they ask you apply to do it, so you just try it and you get it. And in future, as we can see, this is easier than the first derivative test for the polynomials. So for the polynomials, this is a test we preferred. But if they ask you find the interval when it's going to be increasing, decreasing, I'm going to explain it when I go through the review. Then you have to use that first. So let's give you quickly one more example. to see that you may not be able to use it. There is one in your book, so I'm going to explain it. Not many. Okay, most of the time it's fine, but you got to be aware of. Don't be surprised. Don't be shocked. Then you can take care of it. So that's the second one. That should be the one. F of x, very unique example, equal to the 10 x to the 6 minus 24 x to the 5th, okay, plus 15 x to the 4th. This is the one. Again, it's a nice polynomial and seems to be all right to be able to find it. But let's see what's going to be the surprise. Again, the same questions. You want to find the maximum and the minimum, but using the second derivative test. Okay, already step 1, 50%. Find the critical values. Okay, solution. This domain of this function is R. So you are going to solve f prime of x equal to the 0 to get your critical values. Okay, get f prime. F prime of x is equal to the 60, careful, 60x to the 5th minus 5 times 24 would be 120 x to the 4th, and this would be 60 x cubed. So that is f prime highlighted. Okay, let it equal to the 0. F prime of x equal to the 0 to find the critical values. 60 x to the 5th minus 120 x to the 4th plus 60 x cubed equal to the 0. It's a polynomial type, you have to use a factoring method to do it. Okay. What's a common factor? Any suggestion? You have to try to see if you can, there is a common factor because all of them are x.
60x3.
That's it, 60x to the 3rd or cubed, very good. 60x cubed. So you divide 60 out, x to the 5th, and that gives you the leftover x squared. Okay, this one would give us a minus 2x, and this gives us a plus 1 equal to the 0. The difficulty is when you factor out this one, 60x cubed. You see, to find the two numbers that give you x minus 1 times x minus 1. It's like x minus 1 squared. And that will cause difficulty, you see it. Okay, now let the factors to be equal to get the solution. 60x cubed equal to the 0. That would imply x cubed equal to the 0. And that will tell you implies x is equal to the 0. So this is one solution. Then this would give you only one. It's kind of repeated solution, x equal to 1. So we have two critical values. Critical values are going to be 0 and 1. Any question? Now we have to drop them back and then test them. Drop it back to the function to get f of 0, the candidate, remember the value. If you put the 0, you see x, 0, 0, 0, 0. So you won't get anything. So if you put the x equal to the 0, that gives f 0. Okay, this is the 1. Then if you check the 1, what's f of 1? If we replace like 1, that gives it 10 minus 24 plus 15. Okay, plus 15. So I give 25 minus 24, which is equal to 1. So the other candidate is f of 1 equal to the 1. Okay, so this is two candidates that we have. You see, some people, they say, oh, I don't have to check it. I have two numbers, 0 and 1, so this must be minimum, this must be maximum. No, you have to test it. And you'll be surprised. And that's a surprise here. Okay, testing. You see, you've been asked second derivative test. So we have to follow the instruction. So for the second derivative, we have to find the second derivative. Okay, what's the first derivative? You see, this is the first derivative. This is the first derivative. Now bring the second derivative. So what's going to be second derivative? Second derivative would be 5 times 60 would be 300. X to the fourth, and that give a minus 480. Okay, 480 x to the third, and that would be 180 x squared. You see, this is our second derivative. Now we test the number to see the concavity. We have the number of the 0. You see, if you check x equal to the 0, so that give f double prime of 0. You see, 0, 0, 0, 0. Done. Can't do it. Remember, second derivative test cannot be applied if the second derivative is 0, because you can only do it if you can talk about concavity. Okay, so this means the test fails. Okay, the test fails. Even if you put the 1, it's an interesting problem. If you put the 1, it's the same thing. You see, f double prime of 1 would be 300 minus 480 plus 180. That gives you 0 again. So if that was the instruction of this problem, you are done. So you say that the test fails, okay? So SDT, second derivative test, cannot be applied. Okay, so if that's the problem, it's given to you, you're done. But if it was you who decided to use the second derivative test, the problem is not done. So this means you picked the wrong solution, wrong test. So what you have to do is you have to repair it. So the repair is going to be, you have to use the, okay, in this case, one can apply or should apply, can apply the first, okay, first derivative test. Okay, so if it's happened to you, during the problem and you pick the wrong choice, then you do the first derivative test. Remember, for the first derivative test, you need the chart for f prime. You have to go back, get the chart for the f prime, and identify where the function is going to be increasing or decreasing. So let's do the chart to finish it. Again, as I told you, you have only 2 problems in your book. And that's unfortunately kind of even numbers, and you may not see it. That's why we bring this one up here. Okay, so we have to go back and get the chart. So I bring the f prime for myself because I need it. What was the f prime? F prime was, because you have to check the sign of the f prime. This is the f prime for ADXQ. I'm sorry, where is the f prime? F prime is, I think f prime is this one, yes, 60x to the 5th minus 120x to the 4th, okay, plus 60x cubed. Remember, and we factor it out, and that was the one, 60x cubed times x minus 1 all squared. We factor it in this form. That would help us to determine the sign of the f prime. So we need a chart. The chart for the f prime start with the x from negative infinity to positive infinity. You have to put the critical values here. The critical values were 0 and 1. So we get the 0 and 1. So we need to check the sign of the f prime. We check it around these critical values. So 0, 0, because the f prime is 0. And this is the f of x. F of 0 is given to, it's going to be equal to 0. F of 1 is equal to 1. So you have to determine the sign here. You see 1, 2, 3 position. The function is not quadratic, so you have to test some numbers. And that is very, very easy to test. You see, if you want to check the sign of f double prime, look at this one. This is your f double prime, 60x cubed times x minus 1 squared. You see, this part is always positive. So you have to check a sign here only. So you pick a number, you see, between negative infinity and 0. If you pick the negative 1, so if you drop the negative 1 here, okay, the negative 1 here, you see that give you 60 times negative 1 would be a negative number. You see that give you 60 times negative 1 cube, and this is a positive number. So it's going to be kind of negative times positive, which is negative. So that give you negative. And you're going down here. Any question? So between 0 and 1, again, between 0 and 1, you pick another number. If you pick a number, this is always positive. 0 and 1, the numbers are going to be positive, so this is going to be positive always. And it's the same thing if you pick a number like 2 here. So if you pick the 2 here, again, this would be positive. You see f double prime of 2 is positive. You see, that's a difficulty there. You were not able to do it with that second derivative test. Okay, any question? So in this interval, I picked the negative 1. This is going to be this is in fact f prime, not second derivative. Sorry, these are all f prime. Why I put the second derivative? You see, this is f prime, f prime, f prime. It's a first derivative test, just f prime. Okay, so in this interval, I picked the negative 1. So this part is positive. You put the negative 1, 60x cubed would be negative. In this interval, everything is positive, so I don't have to worry about positive, positive. In this interval, we have the 2 against positive. So the function is going to be increasing and increasing. You see, you have only a minimum. You see, then you get the critical point here, and at this critical point, you are not going to get a maximum or a minimum. In some book, they refer to it as a stationary point. But in this book, we just go with the fact that, so the only thing that you have is f of 0 equal to the 0 is a relative minimum. So that's, that's when it's a kind of a special case like this one, this would be the conclusion. So you should be ready for it. Don't be afraid, okay? As soon as it's the test 2 fails, so go and check the test 1. Okay, so just the possibility, but most of the time it's going to be a smooth example. Okay, any question? So that's, we are ready. So I give a break. It's a 9:16. We can come back around 9:25, 9:30. Then I give you one more example of this. It's kind of a fractional one. Then I go over the problem for your test. So I can give you the topics here if you like to know them. So these are going to be the topics for the test. Okay, this is it. 11 question. 5 from your quiz. So you are going to get from the quiz, you get 2 questions on chain rule. Okay, finding derivative as your quiz. Okay, this is it, chain rule. You get 1 chain rule for ordinary function, and you get 1 chain rule for the trigonometric function, as in your quiz. Chain rule and trig functions. Trig functions. Okay, number 3. Of course, we get implicit differentiation. As in your quiz, implicit differentiation. Remember the one that you have to find y prime or dy dx. Number 4, tangent line problem. Tangent line problem. Remember tangent line problem for 2 types of functions, like in your quiz, implicit differentiation and explicit and implicit. Again, as on the one on the quiz. And the number 5, 1 question on related rate, as in your quiz. Related related rates. Those three cases that we have. Remember, we have the ladder, we have the lighthouse, and we have the sphere problem. So these are the 5 like in your quiz. Now the new one question on finding critical values. Okay, we give you 1 question, 2 parts, 2 functions to find it. It's not going to be polynomial, so it may be trigonometric one, maybe a radical function or rational functions, not polynomial. And number 7, finding absolute max, absolute mean, finding absolute, okay, absolute extrema. Of course, on closed interval, remember, we have a test, nice one, easy to do. That's number 7. Number 8, first derivative test. Okay, that's it, first derivative test. They ask you for find the function which is going to be increasing, decreasing. So that would be first derivative test. Number 7, 1 question on mean value theorem, MVT. We give a function and we are going to test you whether the MVT can be applied or not and find all the possible value for the C. That's a 7. Okay, MVT. Number 8. Okay. Number 8 is the one that we did today, concavity. Concavity, number 9. That's going to be number 8, concavity, and number 9 is going to be second derivative test. Okay, so it's almost we cover every topics, I think, that we need to know to make it. You may get 1 or 2 different more from these, but basically this is it. So these are going to be the topics that we cover, and we give 11 questions on this. Okay, so let's have a break. We come back, and you already got these from the previous quiz, quiz. You can study this for yourself. So I give you 1 from each. Test that, the one you have on that test, and of course I give you the complete solutions of that practice test, number 2. Okay.
I have a quick question.
Yes.
What's MVT?
Mean value theorem.
Oh, okay, thank you.
Okay. We are not going to give you rules theorem. Okay. Mean value theorem. Okay, and this is second derivative test, and the other one going to be first derivative test. Okay, so this is going to be the combination that we are going to have. Okay, study 1 from each. Really, you should be fine, and you can bring the formulas that we did it before. And I check your formula sheets; it was all right, so we can have a similar one for this one. Okay, so let's have a break. It's a 9:20. Come back in around 9:30. Be able to do 1 from each, but otherwise you will see the solution. All the tests are done. After your, there is 2 more concepts that we cover over here, and then we go to the second part of the course, which is integration quickly, starting maybe next Wednesday. Okay, see you then. Yes, in about 10-12 minutes. Okay, so I'm going to give you a kind of one from each of these topics, the black one that I've put over here. Okay, so, and I'll grade a couple of problems from your quiz. I'll finish it today. Just be careful when you applying the chain rule. Most of you did very well. For the quotient rule, okay, you know, I prefer to bring it up as a product. Some of you stay with the quotient rule, that's fine, but it takes time. Remember, it takes time for your test, and you better get the habit of bringing it up when it's a quotient, because you are going to use it in the second part of the course. And you know, but I'm fine if you know, if you do it all right. So I will finish the rest this afternoon, and I will post the the result with the solution for you. Okay, so give you one. Some of them that's need to be explained a bit more. You see, I give you 6 types of functions. So we're going to all those 6 really around these concepts. At the beginning of the critical values. Okay, so you see a couple of them here. Practice test number 2. So the first topic that we're going to be interested in is the new one after your quiz, of course, is a critical value. Okay, so in this problem number 1, they ask for the find critical values, critical numbers or values, okay, of each function. So don't expect to give you any polynomial on this question. It may be a rational function or the radical function. So there is a tricky one, and that's a part B. I'm going to explain that one. Okay, for the rest, we have it, and you can check the solution when I post the complete one. So this is number B. Some people, they have difficulty handling the algebra of this problem. Okay, so f of x equal to the 3x to the 5/3, okay, minus 15 x to the 2/3. Remember, you are going to collect the critical values from 2 different sources. The first source is where f prime of x equal to the 0. That give you horizontal tangent line, remember. And the second source is when f prime of x does not exist. So these are 2 sources that you have to check them. For this type of function, both of them would happen. But for the rational function polynomials, you're not going to get the second type. Now we start with the domain first. Okay, you must find the domain first. You can change them to the radical to see that they are going to be, you see, just rewrite it. You don't have to rewrite it now. It's a cube root of x to the 5th minus 15 cube root of x squared. Then you realize that you're dealing with an odd index. And you know that when the index are odd, the domain of the function going to be all real numbers. If you can identify the domain right away, we don't mind. Okay, so the domain is all real numbers. You must check the domain first. Don't try to simplify it. Just keep it as is. Simplify it later. Okay, that would be a step 1, the domain. Now you are going to check this condition. F prime of x equal to 0. Find f prime. So go to the original format, find the f prime. Exponent times coefficients is going to be 3 times 5/3. Okay, x to the 5/3 minus 1. 5 minus 3 is 2/3. Okay, minus 15 times 2/3. X to the 2/3 minus 1. 2 minus 3 would be negative 1/3. Simplify it if you can. These 2 would cancel out. So you get f prime of x equal to the 5x to the 2/3. Okay, these 2 cancel out to get a 5 times 2, 10, minus 10x to a negative 1/3. Okay, since you want to continue any negative power, you are going to bring it down. is going to be 5x to the 2/3 minus 10x to the 1/3. Okay, so that would be your derivative. Now you want to let it equal to the 0 to get these possibilities. Okay, so we go with the f prime x equal to the 0. So we have to solve this equation, 5x to the 2/3 minus 10 over x to the 1/3 equal to the 0. Change it to the radical now. It's going to be 5 cube root of x squared minus 10 over cube root of x equal to the 0. To solve this equation, first you have to get rid of the denominator. You can multiply both sides by the cube root of x cubed and then continue. Or since you have only two terms, you can move one of them to the other side and use cross multiplication. This is the one that I prefer. So it's going to be 5 cube root of x squared equal to the 10 over cube root of x. Now I can use cross multiplication, cross multiply. So that gives you 5 cube root of x squared times it by cube root of x, and this is going to be equal to the 10. Any question? Now we multiply the radicals. You just carry on the radical and you multiply the number inside. X squared times x, and that would be 10. So that would give you 5 cube root of x cubed equal to the 10. See? 5 cube root of x cubed would be 5x. So that gives you 5x equal to the 10. So x would be 2. So you get x equal to 2 as a critical number from the case that f prime of x equal to the 0. Any question? But you are not done. You have to check to see if the possibility of the second case, vertical tangent line, f prime x does not exist. You go to the f prime. So we're checking the second part. I put it over here. So the second part is it possible to have a f prime of x does not exist at any point? You check the f prime here. Down the denominator, you get x to the 1/3. You know that this function is not defined when denominator is equal to the 0. This denominator would be 0 at 0. So you explain that f prime of 0 does not exist. But to check to make sure 0 is in the domain. And x equal to the 0 is in the domain of the function. Because the domain of the function is all real numbers. So x equal to the 0 is also a critical, okay, it's going to be also a critical number. So the conclusion is you are going to have two critical numbers, 0 and 2, and you're done. This second part will happen only for the radical function. It's not going to be happening for the polynomials, trigonometric function, or the rational function. So for those, you don't have to check the second part. You have to check only the first part, f prime equal to the 0. Okay, so that's the best problem of the first group. You can check the solution of the others. There's nothing special for the other problems. Okay, any question? So we give one question, two parts, two functions to find the critical values. Okay, that's topic number 1. The topic number 2 in the order that we talk about it, finding absolute max, absolute mean on the closed interval, very straightforward problem. Okay, this is going to be problem number 2 on this review. We would like to find the absolute. Okay, absolute extrema means the maximum and the minimum on the closed interval. Close the interval. Very straightforward problem. Okay, and this is it. Most of the time it's a kind of a polynomial type. So I do the part 1. The function is f of x. I did the part 2 during the lecture. x to the fourth minus 18x squared and minus 1. And the interval is -4 and 0. Okay, you are interested in the largest value and the smallest value of the function. Okay, no test is needed for this one. Remember, we use the Cauchy theorem. So what we are going to do, we find the candidate, we find the f prime critical values first. So we check to make sure the critical values are inside. Then we find the value of the function at the critical values, and we find f of -4 and f of 0. Compare them together. The largest value is absolute maximum. The smallest value is absolute minimum. Okay, no test is needed, remember. So very straightforward problem. Solution. That's it. So the domain in this problem, it's a polynomial, but make sure you stay with this domain. Okay, that's the domain part. Differentiate f prime of x equal to the 4x cubed minus 18x. This is the only source that you're going to get your critical values. Okay, sorry, 2 times 18, 36. That would be 36. Okay, I rewrite it. 4x cubed minus 36x. Let it equal to the 0. Factoring method to solve it. 4x out. So that gives x squared minus 9 equal to the 0. You can handle the other one, but you can factor it as well. So these are going to be the case. So you have 3 solutions: x equal to the 0, x equal to 3, x equal to the -3. So your critical values are going to be -3, 0, and 3. Any question? So you make sure that these numbers are inside this. Okay, so you check with your domain. Okay, the domain is -4 and 0. And you check to make sure the numbers are inside. -4, sorry, this is not one. -3 is inside, 0 is inside, but 3 is not. So you take the 3 out. Okay, you are not going to carry all these points. Okay, so x equal to 3 is not in D. So you are going to update your critical values. So the critical values are going to be only -3 and 0. Any question? So the candidates are going to be now. You have to find f of 0, f of -3, and f of -4, compare them together. Okay, we usually get the chart. X, f of x, which is x to the 4th minus 18x squared minus 1. So we have to find f of 0, f of -3, and f of -4 only. Make sure don't bring the 3 here, because 3 is not in your domain. Okay, substitute over here, that gives you 0 minus 1, which is a -1. This is one candidate. -3, -3 to the 4th, minus 18 times -3 squared minus 1. -3 to the 4th would be 81. -3 squared would be 9. 9 times 18. Okay. It's going to be, I think, the 162 and the minus 1. So that gives you -81 minus 1, which is a -82. Okay, so this is going to be the second possibilities over here. Okay, so we pick the -4, drop the -4, -4 cubed minus 18 times the -4 squared minus 1. Check this one. -4 cubed. -4 to the 4th. 16, 64, 256. 256 minus -4 squared root of 16. 16 times 18. 288. You can check it with your calculator, and this would be -1. Okay, so that would be 256 minus 289. So the result is -33. That's it. Any question? Compare these values together. The smallest one is the minimum. So the minimum value of a function is -82. And the maximum value of the function is -1, and you're done. Okay, so this is the way you do the absolute max, absolute mean. No test is needed, okay, because by the Cauchy theorem, we already got the idea of how we're going to locate this maximum and the minimum. Okay, question. There's one more trigonometric one. You can check my solution, or we did it during the lecture. So this is the third topics. The next one, mean value theorem. Okay, we give a function easy an interval. You check to see if that function satisfies the mean value theorem, MVT, and of course it would satisfy. So this would be number 3. Number 3, checking the mean value theorem. So this is it. We want to determine if the function, if you like, or if the mean value theorem, MVT, can be applied. Okay, and if so, you just find all the value of the C, the mean value theorem. Okay, they're all the same, and just do one of them for you. Number part 1 is going to be, we give you a polynomial type again, like the one here. So f of x equal to x cubed minus 2x plus 1. This is the function, and you want to test it on this interval. You have to nicely explain the theorem for us, otherwise you are not going to get a full credit. Okay, condition of the mean value theorem. Condition 1 is continuity. Condition 2 is differentiability. Then you write the formula and you find the C. Okay, so this is how we're going to explain it. Solution. You explain the continuity for us. Okay, condition 1. This is the polynomial. It's continuous. It's continuous everywhere, but the theorem asks for the closed interval. So we say f is a polynomial. F is a polynomial. Okay, and it's continuous. It's continuous on the closed interval of -2 and 3. That's it. Don't say it's clear. Yes, it's clear, but you have to write it down. Give us the reason. Any question? So that's the first condition. Second condition, differentiability. Differentiated. No big deal. Derivative exists. That's it. Carefully differentiated. That's going to be 3x squared minus 2. Since you can find the derivative, it's differentiable. And f is differentiable. It's differentiable everywhere, but the theorem asks for the open interval. On the open interval of a -2 and 3. Done. Okay, both conditions satisfy. So we can use the mean value theorem. Okay, it's mostly polynomial, so it can be used all the time. So we say MVT can be applied. Can be applied. Okay, to find the C. To find a number C. This is just for information. You can go ahead and find it. Inside -2 and 3, such that now the condition of a theorem, remember, f prime of C equal to f of B minus f of A. B is the bigger number, A is the smaller number. F of 3 minus f of -2 divided by B minus A. It's like the slope of a secant line. Okay, so going to be 3 minus, make sure don't make a mistake, is a negative minus -2. Okay, that's a statement of the mean value theorem. Stay on the right, 3 plus 2 would be 5. It's going to be 3 plus 2, so it's going to be f prime of c equal to f of -3 minus f of -2 divided by 5. So you have to go and bring in for us what is f of 3, what is f of -2, and f prime of c. Then you cross multiply and get the c. Okay, for f of 3 and f of -2, we have go to the function. For f prime of c is already f prime of x here. Replace x by c. Okay, so go and find it, f of 3 into the function. F of 3, it's a 3 cubed minus 2 times 3 plus 1. 3 cubed, 27, 6, 1. So that gives it 22. Okay, so that's f of 3. F of -2. F of -2 is a -2 cubed minus 2 times the -2 plus 1. -2 cubed, -8 plus 4 plus 1. And that gives you -8 plus 5, which is a -3. That's it. F prime of c, the f prime of x is 3x squared, just change it to the c. F prime of c is a 3c squared. 3c squared minus 2. Go back, substitute here, and solve the result of the equation. Any question? So substitute f prime of c, so that gives us, that's it, 3c squared. Okay, 3c squared minus 2, which is going to be equal to the top f of 3, which is a 22, minus f of -2, which is -3. Make sure, just apply these negative signs. Divide by 5. Stay to the right to simplify. So that gives it 22 plus 3 over 5. So that gives it 25 over 5, which is 5. Move it to the other side and decide what you want to do. Okay, it's going to be 3c squared minus 2 minus 5 equal to the 0. So that gives it 3c squared minus 7 equal to the 0. You see, if you have 3 terms, use quadratic formula or factoring. If you have only 2 terms, you can solve it for c squared right away and get the result. Make sure you handle this part all right. Okay, so that's easy. 3c squared equal to the 7. C squared equal to the 7/2. You take the square root, c would be positive, negative, radical 7/2. You will use your calculator to find it, because you have to make sure that this is inside the interval, okay? So we usually get this one by calculator. Let's see if I can get this one right. So it's the square root of 7 divided by 2, 3.5. 3.5. I have 1.87. Okay, so this is going to be c equal to,
Sorry, shouldn't it be 7/3?
oh yes, you're right, excellent. 7/3. So 7/3. So I have to do this one again to check it. Okay, so it's going to be 7 divided by 3 this time, yes. 152 or 153. So I have c equal to positive, negative 150. Okay, 52 or 53. Remember, these must be inside the interval. Both of them are inside -2 and 3, so we accept them. Okay, are inside. Remember, it cannot be -2 or just a +3. Must be inside. You see, one problem, one solution would be fine. But if you get two solutions, you have to make sure that both of them are inside. Okay, just have a look. You don't have to test it, but that's why when it's a radical, you have to use your calculator and check that 1.553 to make sure that both numbers are inside the interval, and then you're done. That's it. Any question? A straightforward problem, but it's very important concept. We talk about it. So we give you 1 on this test and 1 on the final. The mean value, we check it again because it's using calculus 2 and in calculus 3, and we are going to use it through this course. So that will take care of the question on mean value. Okay, straightforward. Don't miss it. Be precise. If you don't write this condition first and the second, you will miss something like 2-3 points of that 10 points of this problem. Okay, because you have to show us that you did understand. Or it's part of the day really that we have to check that it's happened. It's always it can be applied on the test. Okay, so that would cover our question number 3. Any question? Now that will take us to the test that we have. First derivative test. For the first derivative test, we have a couple of problems over here. Okay, it's number 4. Okay, number 4, number 4, number 5. I think both of them are the case. Yes, number 4, 5. And these are going to be first derivative test. First derivative test. They are not going to give you the first derivative test, but as soon as they say determine where the function is going to be increasing, decreasing, and finding the relative max mean, this means you have to use the first derivative test. You cannot use the second derivative test for this, remember. Okay, so this is how you find out. You've been asked to determine the interval. Okay, the interval where the function, you say this expression means first derivative, where the function is increasing, okay, increasing or decreasing. It's the first, and then they say find all relative, okay, relative extrema. So this means you have to apply the first derivatives. That's it. It may be a trigonometric one, or it may be, okay, polynomial. So we usually give you 2 problems on this one, and you have 2 over here. So I check the first one because I know that there is something special about this first one that I wanted to show you. But that the other part is the one that I did during the lecture, x minus 2 cosine x. Then you can check the solution yourself, okay? So this is the number 4 that I have. And so the function is, I remember there was something special about this one. Let me see. What was the case that I put it here? I don't remember, but there is something special about this function. Okay, let's check it to see why I put this one here. Okay, so there you are. You know that you have to find the critical values as usual. Then in order to test that first derivative test, you need a chart for f prime to do it. This is the way we do this one, okay? So there you are, solution. Start with the domain always. Domain is all real numbers. So it's a polynomial to get the critical values. There is no sharp corner type, okay? These are all polynomials. So carefully differentiate it. So that gives you f prime of x, which is going to be equal to the 5x to the 4th minus 16x cubed. That is going to be f prime.
The last term is actually 4x to the 3rd.
4x to the 3rd. Let me just check to make sure. Yes, you are right. Thank you. So that makes it more exciting now. Or x to the 3rd. So we are going to have a 12x squared. Okay, so we get a 12, differentiate 12x to the 3rd. Okay, everything is all right. Okay, So that would be our derivative. It's important, just check the derivative. So this is f prime. So we have to let it equal to the 0 to get the critical values. F prime of x equal to the 0. And this is 5x to the 4th minus 16x cubed plus 12x squared equal to the 0. Okay, when the higher, we get a higher degree type. So we try the factoring. So in this case, there is a common factor, which is going to be x squared. Okay, pull out the x squared as a factor. So the leftover is going to be 5x squared minus 16x plus 12 equal to the 0. Okay. So the inside one, you can use the quadratic formula, or you can factor it. So intentionally, I think I'll go with the quadratic to just show you that you may need it. So one of the solution is clear so far, x squared equal to the 0. So x would be 0. This is one solution, and for the other one, 5x squared minus 16x plus 12 equal to the 0. You may try factoring, but the safest one may be just using the quadratic formula. So I just remind you, negative b plus or minus the square root of b squared minus 4ac. This would be fine, but I just want to remind you in this method. You may need it for the mean value theorem. Okay, negative and negative 16. This is going to be the case, plus or minus. Okay, so that gives you 16 squared. But 16 squared, I think it's 256. Okay, and this is going to be minus 4ac minus 4 times 5 times 12. Okay, divided by 2a, which is 2 times 5. So we continue on the top. That gives us a 16 plus or minus. So that gives you 256 minus, and this is going to be what? 4 times 5 would be 20. That gives it 240, which is a nice number. Okay, so that gives 16 plus or minus the square root of 16, okay, over 10. So that gives you 4. So it was factorable, but again, I just did it to show you that, no big deal. So it's a 16 plus 4 over 10 is 20 over 10, which is equal to 2. And this is going to be 16 minus 4 over 10, which is going to be 1210. And if you simplify it, okay, if you simplify it by 2, so that gives you 6/5. So we have two critical values. Okay, the critical values are going to be 2 and 6/5. So you have 2 over here, of course, and 1 over there. So it's going to be 0. Okay, we get 0, 2, and the 6/5. Any question? So let's see. I know what is special about this one. So we have three critical values. We have to go back to wrap it back into the function and then get a chart to test it. Okay, so going back to the function substitute. So we are going to get f of 0 into the original function, which is going to be this one, x to the 5th minus 4x cubed plus 4x cubed. If you put the 0, everything is 0. So we get the 0 here. Okay, and then f of 2. So we get f of 2, which is going to be 2 to the 5th, okay, minus 4, 2 to the 4th plus 4 times 2 cubed. Okay, we check this one, 2 to the 5th would be 32. Okay, that gives you 32. And this is going to be 64. Okay, 64, and that would be 8, and that would be 32. So this seems to be 0 as well. Okay, so f of 0 would be 0, and that was 2 to the 5th, which is a 32, 16. That gives me 64, and that's going to be 8 and 30, 32. Okay, so we check the f of, you have to use your calculator, f of 6/5. Okay, so just somebody use your, use your calculator, give us these numbers if you can, or like check it. You can think about it as a 1.2 if you like. Okay, it's going to be f of 1.2, and this is going to be 1.2 to the fifth. Okay, minus 4 times 1.2 to the fourth plus 4 times 1.2 cubed. Can you use your calculator? Give us this number if you have it. I don't have the number.
1.2 to the fifth is 2.49.
Equal to what? 1 point? Just round it. All of them together. Do you have the final answer?
Uh, 1.106.
Okay, 1.106. Okay, 1.2. Yeah. Okay. 1 point. Okay, almost. So that's it. These are the candidates. We need a chart to be able to take care of it. Okay, that chart would be interesting to get these numbers. Okay, so this is probably from your book that I picked this one because there is going to be something special here. So we need a chart. These are the candidates. Okay, the chart for the first derivative test would be, if we get the x here, okay, x, the domain is a negative infinity to positive infinity. So you have to list your critical numbers. So you have the 0 here, okay, then the 6/5, which is a 1.2, and you have the 2. Then you go with the f prime. Okay, this is going to be your f prime of x. And this is going to be f prime, and f prime is going to be 0 in 3 places. That's going to be 1, 2, 3. Okay, so that gives you the f prime. Then finally, we get the f of x over here. Then the value that we have, f of 0 is equal to the 0. Okay, f of 6/5 is 1.2. And f of 2 is equal to the 0. Okay, that's going to be the one. So you have to determine the sign of the f prime. You can get help from these numbers here. Otherwise, you have to test some numbers. So from 0 to 1.2, this is increase. So f prime would be positive. From 1.2 to 0, this is going to be decrease. So f prime would be negative. Okay, then you have to check a number here just to find out. Later on, we find out, when x goes to negative infinity at the next section, we are going to check the negative infinity in the leading term, which is x to the fifth. That would be negative infinity. But, you can check a number if you like between negative infinity and 0. If you pick something like a -1 as the test number into the f prime, then you realize that this would be also positive. Okay, this would be positive. The other indication is that you see x squared here. This is going to be the x squared. So around the 0, this would be always positive. So this would be positive. So that give you increasing. That's why we give you this number. And over here, 2 and positive infinity, x goes to positive infinity, x to the fifth would be positive. You see, or you can check some number, we can check 3 if you like. And so that gives you positive as well. Okay, that's going to be the one. A different way to do it. The other way to do it is you can ignore the 0. This inside is kind of quadratic. Okay, and we talk about it. When it's quadratic, between the solutions, the sign is opposite sign of the x squared, which is negative. Outside is going to be positive. Done. You don't need anything else. Okay, to determine this, the sign that you're going to have. Okay, any question? So this is going to be the case. Okay, test numbers or around the x squared is always positive. So between the solution, the sign is negative, outside positive, or just get help from this bottom one. This is why I gave you this problem, you see. 0 is the critical value, but around the 0, nothing is happened. Up, up, up. But up, down, this is a maximum. Down, up, this is a minimum. So this means f of 650 equal to the 1.2 is a relative maximum. F of 2 equal to the 0 is a relative minimum. At 0, we won't get anything. They call it a stationary point again. Okay, so that's why I pick, I was not sure about why I gave you this one. But this is the way we're going to do the problem of the first derivative test first. Any question? So it may be a polynomial or it may be a trigonometric one. You check the trigonometric one that I test during the lecture. And of course, number 5 is trigonometric, and then you can see my solution. Okay, so that would take care of the first derivative test. We may give you 2 problems with this one. Any question? So let's quickly do the last 2. The next one is concavity, and the last one is the second derivative test, the one that we did today. So the concavity is question number 6. Again, a straightforward problem, but some people, they confuse this one. They mixed up this one with the first derivative test or the second derivative test. You see, just concavity. You want to find the direction. You are not interested in maximum, minimum, nothing. You are interested in the concave upward, concave downward, and the inflection points. So you find f double prime and you let it equal to the 0 and you get the problem, okay? So this is how they are going to ask you. You want to determine the interval. Okay, determine the interval. The intervals where the graph of the function, is concave upward, or concave downward. You see, you will see that this is nothing to do with the max minimum. And they ask for find any possible inflection point or points. You see, for this problem, this is your instruction. Solve f double prime of x equal to 0. That's it. Don't stop at the f prime because they are not interested in the maximum and the minimum, okay? Go up to the f double prime, let it equal to the 0. That gives you the possibility for the inflection point. Then get the chart and tell us what will happen to it. Okay, that's it. And the best one is part 1. The function is a very famous function. We are going to graph this one later. X to the 4th minus 2x squared plus 3. So we give you a polynomial type. Easily can be done. Okay, are you ready? So you see concavity. This is it. Concavity f double prime equal to 0. So start with the domain. It's a polynomial. Domain is all real numbers. Since concavity problem, solve. I repeat it again. F double prime of x equal to 0. Differentiate f prime 4x cubed minus 4x. Don't stop here. Go on. Go on to get to the f double prime. F double prime of x. 12x squared minus 4. You stop here. All your operations are going to be here.
Wouldn't it be 16? Or sorry, never mind.
Okay. Yeah, is that right? 4x cubed. No, 4x. Okay, so f double prime, let it equal to 0. Nicely solve this equation. It's only two terms, so you don't need quadratic formula. Move it to the other side. Find the x squared, 4/12, which is a 1/3. Use the square root, two solutions. Positive, negative, 1/3. You can use your calculator, or just this is not a nice, not a bad number. So if you like, you can keep it. So it's going to be kind of 1/radical 3, or whatever, how far you want to go. Okay, or calculator. So this is the possibilities for the inflection points. So whatever you pick, you have to go back into the function and substitute. So if you pick this one, you have to find the values. One of them would be enough. Just check one. F of radical 3/3, for example. You go to the function that give you radical 3/3 to the 4th minus 2 times radical 3/3 squared plus 2. Again, calculator can be operated easily, or this one is not difficult because the top, because radical, that radical 3 squared would be 3. Then 3 squared would be 9. So it's going to be 9 over what? Over 81. And it's going to be minus 2 times, and this is going to be 39 plus 3. If you use this one, would be easier, 1/radical 3. So that's it. So that gives you 19. So it's going to be 19. And this is going to be minus 69 plus 3. So the common denominator, or just calculator. That gives you negative 59 plus 3, 27, 22, 9. Again, with your calculator. So so that gives you the value. Even if you go with the negative, it's the same thing. So positive, negative, radical 3/2 give you 22/9. So these are the candidates for the inflection points. Any question? We need a chart. Some people stop here and they claim that this is inflection point. No, you're not done. You have to give us concavity, remember? So you solve this equation and then give us a chart. Nice chart. That's it. Chart for the concavity. X, negative infinity to positive infinity. Possibility, 2 points, negative radical 3/3 and the radical 3/3. We're checking F double prime. And we're checking concavity. Concavity. Double F prime is 0 here. And these are 22/9 and a 22/9. You bring F double prime to check the signs. Otherwise, you check some numbers. What is your F double prime? What's F double prime? 12x squared minus 4. That's easy to determine the sign. You can test numbers, but it's quadratic, remember? When it's a quadratic, between the solution, opposite sign of the x squared. Sign of the x squared is positive, so the opposite would be negative. Negative, positive, positive. If you don't like it, you have to test 3 numbers between these. But when it's quadratic, again, I repeat it. When it's quadratic, between the solution, opposite sign of the x squared. Coefficient of x squared is 12. 12 is a positive number, so the opposite would be negative. Negative, positive, positive. That's it. Positive concave, remember, up. Negative concave down. Positive concave up. That's it. You can graph it even, you see. So up, down, inflection point. Up, down, inflection point. That's it. If you give us the chart, we are satisfied. that it's going to be concave up between negative infinity and negative radical 3/3, and between radical 3/3 and positive infinity, and concave down in between. But usually identify only the inflection points. The chart would be fine, I accept it, but I just write down for you. One of them is negative radical 3 at 22/9, and the other one is positive radical 3/3, 22/9, and with that. See, that's a concavity problem. Okay, don't miss it. No critical values. Don't waste your time. I've given this one several times. I see that the people, they go and find, the maximum, the minimum. No, it's concavity problem. Okay, we give you one of them. Any question? So that will take us to the last problem, and in fact, an interesting example. Number 8, second derivative test. Second derivative test. We are going to give instruction. Instruction is apply, so you have to. The second derivative test. Second derivative test. Okay, to find the maximum and the minimum, to find relative extrema. This function, in fact, is interesting. We didn't have the example of this, so that's good to know. This is going to be used in application problems later on. We have a group of them of these 4. F of x equal to the 1 plus x plus 4/x². And they give you the kind of a domain, the interval. Yes, that should be 1. It's okay. So that's given. You can do it. You see? So what you have to do is you have to find critical values first. The domain of this function is everything except 0. So solution is going to be the domain of this function is going to be anything except 0. So negative infinity to 0, union with 0 and positive infinity. So I suggest to move this one up because you want to differentiate it twice. Okay, you have to find the critical values first. So that part would be fun. F prime, drift of 1 is 0, drift of x is 1. This would be negative 8x to the negative 3. Make sure you don't miss this one. Some people use quotient rule. You can do it if you like. But this is easier. That's F prime. Let it equal to the 0. So you have to solve this equation. Since you want to solve the equation, change it to the positive power. 1 minus 8/x³ equal to the 0. You have to get rid of this denominator. You can multiply by x³ or just move to the other side, cross multiply. That's easier. There are a group of them of this type. Use cross multiplication, cross multiply. x³ equal to the 8. Take the cube root. There is no positive negative, remember. And x would be 2. No complex numbers. Don't use some other softwares online and say we have 3 solutions. Bring the eyes. No. That's it. We have 1 critical value. Drop it back into the function and test it. What is f of 2? Function 1 plus 2 plus 4 over 2². 1 plus 2 plus 4/4. So 1, 2, 1, 4. So f of 2 equal to the 4 is the candidate, or the maximum or a minimum. I just want to give you an excuse to remind you how to solve this type of equation in this course. Okay, now we need to test it. You have two choices in general, first derivative, second, but they ask for the second. So the testing second, you have to find the second derivative, rub the numbers in, check to see whether it's concave up or it's concave down, okay? So I quickly do this one for you, right on time, finish it. So testing, some people, they don't test it, you see, testing. Second derivative test. So I need the second derivative. So I bring the first derivative. F prime was 1 minus 8x to the negative. Check it. Negative 3. Differentiate it again. F double prime. Carefully. If O1 0. Negative 3 times negative 8 would be positive 24. 1 down, x to the negative 4. So this is going to be 24, x to the negative 4. In fact, is going to be f double prime of x is 24 over x to the 4th. But what you have, your critical value is what? 2. It's already positive, of course. Drop the 2 in. That give you 24 over 2 to the 4th, which is a positive number. You don't have to worry about the value. It's positive. Even you can say here it's positive. Second derivative positive, remember that's the concavity. So positive means up. Up means minimum. That's it. If it's a negative, it's down negative. So f of 2 equal to the 4 is a relative minimum. In fact, it's absolute minimum because you don't have anything else to compare, you see. You have only one critical value, and at that critical value, you get a minimum. So this is in fact f of 2 equal to the 4 is absolute minimum, you know, but relative would be fine, but you can say also absolute mean. And then you're done. That's it. Any question? So I did 6 examples for you. One from each would be given on the test. You get 6 here, 5 on the quiz, 5 and 6, 11. So study this. Okay, just pick the similar one from your practice one, from your assignment, from your quiz, and you should be getting an excellent grade on this one, really. We don't have usually difficulty on this. Get an excellent grade on this. You're done with the 2 tests. You can drop the lowest tests. Of course, you know, you're going to have a test 3, but it's very good place and the topics. So study for the test. And that's it. If you have any question, let me know. Okay, I'll, when I get time, I just push them together and I post it for you. But I have to go to do the similar one for a couple of minutes for my calculus 3 class. Okay, have a good one. Let me know if you need anything. Again, I repeat it. If your test number is missing, email me, tell me when did you take it and where did you take it, so I can follow that and get the result for you. Okay, have a good one and good luck. Make sure to make an appointment for your test. Otherwise, you can't do it.
Sorry, real fast. Are we allowed to bring a formula sheet to this test as well?
Yes, as usual.
Okay.
The time for the test is 2 hours and 30 minutes. When you make an appointment, 2 hours and 30 minutes. 11 questions, you answer 10. You can bring 1-page formula sheet, double-sided. Okay, 1 page only, double-sided. Just the formulas.
Thank
Okay.
you.
Okay, have a good one. Bye-bye.